Betty decides to breed and sell Siamese fighting fish. The costs associated can be mapped by the following function. C of x is 500 plus 7x, take away the square root of x plus 10, in dollars, where x is the number of fish bred and sold. If each fish is sold for $20, determine an expression for the profit function and simplify your answer. Well, the profit function is always the revenue function take away the cost function. And of course, we were given the cost function just here. We're told each fish is sold for $20. So if we sell X fish, the revenue will be 20x. So our profit function is going to be 20x, take away 500 plus 7x, take away the square root of x plus 10. So 20x take away 7x, that's going to be 13x, take away 500 plus the square root of x plus 10. We now want the profit or loss made when 90 fish are sold. So P of 90 is going to be 13 times 90, take away 500 plus the square root of 100, which is of course 10. So we're going to calculate this. So that's going to be 13 times 90, take away 500, add 10, gives me $680. And in this case, that is a profit. We now want the profit made on the 390th fish sold. So if I do P390, that would be the profit on selling 390 fish. If we just want the profit with the 390th fish, what we need to do is take away the profit on 389 fish. So we're going to have 13 times 390, take away 500, plus the square root of 400. That's 4590. Take away, we want the same thing with 389. So we're going to have 13 times 389, take away 500, and add the square root of 399. And that's 4576.97. And so our profit is going to be 4590, take away my last answer, which is 1303. We want an expression for the marginal profit. Now the marginal profit is P dashed. So it's what you get when you differentiate the profit. So that is going to be, so remember what we've got here is 13x minus 500 plus x plus 10 to the power a half. So we're going to get 13. The 500 of course will disappear. And then when we differentiate this, we're going to get a half, x plus 10 to the negative half. Using the chain rule, the differential of the inside here is just 1. And so we can simplify this to 1 over twice the square root of x plus 10. So we get 13 plus 1 over 2 times the square root of x plus 10. Before I move on to the next part of the question, what happens when we evaluate p dashed of 389? So what I'm going to do is p dashed of 389. So let's just calculate that. So I'm going to get 13 plus 1 over 2 times the square root of 399. Notice it's very close to our last answer. If you think back to when we looked at small increments, small changes, this is estimating the value at the next integer value up using a tangent. So when we did the calculation here, we did it exactly. We went from 389 and we worked out the value at 390, and the difference between those was 13.03. What we're doing with the marginal profit is using the tangent to give us that approximation. And in this case, it's a very good approximation. So let's go ahead and look at the next part of the question. Determine the marginal profit when x is 215. So we're going to have 13 add 1 over 2 times the square root of 225. So 215 add 10. And that gives me 13.03. Explain what your answer to 1 means. It's an estimate of the profit, and I'm coming back to this description over here. It's an estimate of the profit when the 216th fish is sold. So it's the next one up after 215 because we're using the tangent to project forward